Hello students. So in the today's lecture we are going to study the numericals based on Henderson-Hasselbalch equation. Dear student, please remember that whenever I am taking the lectures of numerical based, you have to write that numericals, try to solve them and also try to solve the numericals which are given in the books. So now let's begin with our lecture. So our first numerical is a buffer solution containing 0.25 molar acetic acid and 0.50 molar sodium acetate. Calculate the pH of acidic buffer solution if the ionization constant of acetic acid is 1.82 into 10 raised to minus 5. So first of all, before solving any numerical, we will write the given things. A buffer solution containing 0.25 molar acetic acid. That means concentration of acid is given to us and that is equal to 0.25 moles. And 0.50 molar sodium acetate. So sodium acetate is a salt and the concentration of salt is equal to 0.50 mole. Okay. What we have asked, calculate the pH of acidic buffer if the ionization constant of acetic acid is 1.82 into 10 raised to minus 5. So ionization constant is denoted by Ka, which is equal to 1.82 into 10 raised to minus 5. And we have to find the pH. We know the Henderson-Hasselbalch equation, that is pH is equal to pKa plus log of concentration of salt upon concentration of acid. Okay, but here in our question the value of Ka is given to us, not the value of pKa. We know that pKa is equal to minus log of Ka. So now minus log of 1.82 into 10 raised to minus 5 we have to find. That we will find in the calci. So now in the calci we will type log into the bracket 1.82 into 10 raised to. So when you have to give the raised to, you have to click on the upper arrow into 10 raised to minus 5 and don't forget to close the bracket. And that is equal to minus this minus as it is, and the answer is minus 4.739. Okay, so this minus minus becomes plus, so therefore pKa is equal to 4.739. okay now. So now we will put the values. pH is equal to pK value is 4.739 plus log of salt concentration is 0.50 upon 0.25. So 4.739 will be as it is log of this division is equal to 2. So pH is equal to 4.739 plus log of 2 is 0.3010 plus this 4.739 which is equal to 5.040. Okay, therefore the pH is equal to 5.04. Okay, this is the answer. Calculate the pH of buffer solution obtaining by mixing the 50 ml of 0.1 molar ammonium hydroxide with 50 ml of 0.02 molar ammonium chloride. If the ionization constant of ammonium hydroxide is 1.8 into 10 raised to minus 5. Again we will write the given thing. Now here see the concentration is given in the another form, that is the weak base is taken as 50 ml of 0.1 molar and the salt is taken 50 ml of 0.02 molar. Okay, this is the given things, and Ka is equal to 1.8 into 10 raised to minus 5. Now first of all we have to find the pH. We have to find the pH. Now for finding the pH, first of all we will find the pOH by the Henderson-Hasselbalch equation. So for that, here it is not pK, it is a pKb. It will be Kb, ionization constant of weak base. So we know that pKb is equal to minus log of Kb. So minus log of 1.8 into 10 raised to minus 5 is equal to 4.739. Okay, so we have got the pKb. Now we have to find the concentration of base. So concentration of base is found out like this. So the total acidic basic buffer solution is 50 plus 50, it is 100. Okay, therefore 50 into 0.1 upon the total solution, that is 100. So now which will be equal to 0.05 molar. Okay, similarly for the salt, so 50 ml salt of 0.02 molar concentration in the 100 ml basic buffer solution. Now it is equal to 0.01 molar. Okay, we know that pOH is equal to pKb plus log of concentration of salt upon concentration of base. Now putting the values, pOH is equal to pKb is equal to 4.739 plus log of salt concentration is 0.01 upon 0.05. So 4.739 plus log of this, the division is equal to 0.2. Now log of 0.2 is 4.739 minus 0.739 698. And this subtraction comes to be equal to 4.040. Okay. This is the value of pOH. But you don't have to stop here. You have to first see the question that there is a calculate the pH. So we know that pH is equal to 14 minus pOH. So now 14 minus 4.040 is equal to 9.959. Okay, this is the value of pH. This is the answer for this question. Next question is, calculate the pH of buffer solution obtained by mixing 10 gram of acetic acid and 15 gram of sodium acetate and making the volume of solution to 1000 ml. Given the pKa is equal to 4.74, molecular weight of acetic acid is equal to 60 gram per mole and molecular weight of sodium acetate is equal to 82 gram per mole. Okay, so basically we must know that this equation that 1 molar 1000 ml is equal to the molecular weight expressed in gram per mole. Okay, so now here we have to find this x molar of 1000 ml. The given weight is 10 gram. For this is for the acetic acid. Okay. Therefore, x is equal to 10 gram into 1000 ml upon to 1 mole. The molecular weight of acetic acid is 60 gram per mole into this 1000 ml. So now this 1000 ml and 1000 ml gets cancelled. 10 divided by 6 is equal to 1.66 molar. Okay, this is concentration of acetic acid. Okay, now similarly for the sodium acetate, 1 molar 1000 ml, the molecular weight of sodium acetate is 82 gram per mole. So this is for sodium acetate. Okay, so x molar, the concentration we have to find. It is also dissolved in a 1000 ml. The weight is 15 gram. Okay. Therefore, x is equal to 15 into 1000 ml, 1 molar upon 82 gram per mole into 1000 ml. So this gets cancelled. 15 divided by 82 is equal to 0.182. This is in the moles per liter. This is the concentration of sodium acetate. So from this we have got the concentration of acid is equal to 1.66 molar and the concentration of salt is equal to 0.182 molar. Okay. Now, in the given, the pKa is equal to 4.74. We have to find the pH. According to Henderson-Hasselbalch equation, pH is equal to pKa plus log of concentration of salt upon concentration of acid. So, pKa is 4.74 plus log of concentration of salt is 0.182 upon 1.66. So 4.74 plus log of this division is equal to 0.1096. That 4.74, this log is equal to minus 0.9600. So this subtraction comes to be equal to 3.779. So the pH of the solution is 3.779. Okay. So in this lecture we have studied the numericals based on Henderson-Hasselbalch equation. So you have to solve all the numericals that are given below the lesson in the textbook. Try to solve that all numericals. If there is any difficulty in solving that numericals, ask me on the Google Classroom. I will solve it and explain you. Okay? Thank you.